I'm Steve Wright, and I do Nuke training. I travel around the world to visual effects facilities, and a lot of the training I've been doing lately has been stereo conversion. And also, they've been asking for mocha with Nuke stereo conversion training. So I'm here today to show you how mocha is used to do stereo conversion with Nuke. The emphasis, of course, is on mocha. The thing that I like about mocha is it has the planar tracker. That's the core technology behind mocha. And the planar tracker is used for several different things. It can do a remove process to make a clean plate. It can do an insert process like a monitor insert. But for me, the most important feature is using the planar tracker as a roto assist. So tracking on planar surfaces like the carpet or the wall is what it was designed for, but we can use it to track surfaces on a compound curved surface like this boy. So it cannot do all of the work for you, but it'll speed up the process and be a force multiplier. So what I need to do for this stereo conversion is I need to separate the boy from the background. I also need to push this rock wall back and pull this rock wall forward. And to do that, I'm going to need some masks. And since I have a moving camera, those masks are going to have to be animated. So we'll start by tracking the background. I'm going to run a nice careful shape out here, and let me adjust this point down there. Okay, let me show you that. Now the problem with this is that the boy is moving in front of my area that I want to track. So having that motion in there is going to spoof the tracker. I can fix that very easily by layering the order so that the boy is subtracted. The boy now is a holdout mat over the background. The tracker will no longer be confused. By the way, I need this data, so I'm going to call this my BG track. Okay, we'll track forward on this, and the planar tracker is remarkably swift. It'll only take a few seconds to track this background plate, and once I have it done, I can show you how this shape is now locked to that background. Okay, we'll just play that right now. So you can see that shape is now locked to the background. We'll stop that, go to the beginning of the clip, and turn off the matte display. The next thing I'll need is this rock wall here. I want it to be pulled towards the camera, so I'm going to need a depth map on that. So what I'm going to do is come down here. I'll turn off that track, go get a new roto, draw a shape here, and soften it up a bit, like so. Now, as you can see, it's not tracked with the background. It's not moving with my camera. So all I have to do, and I'm going to rename this for that bulge that I want in the wall, bulge mask. To make it track, all I have to do is connect it to the existing background track. And now that mask will move with my camera. Similarly, I need a mask for the rock wall. To do that, I've already drawn that, so you don't have to watch me draw a complicated shape. All I have to do is take that and again hook that to the same background track. And now that mask is also moving with it. Here, let me punch these up for you. There you go. So I now have these moving with the background with my camera, and I now need to export them to Nuke. To do that, I'll just select the mask I want to export. Come down here to export the shape, make sure I've selected the Nuke, and I'll copy it to the clipboard, and watch the elegance with which these shapes can be imported to Nuke. We'll switch over to Nuke, and I'll zoom in here and paste that and hook it up to the viewer. So there is that shape that I just brought in from Mocha, and it's already tracked. It's got all the animation built into it. All right, so let's go back to Mocha and take a look at how we'll make our clean plate. So I'm going to turn these off, turn on the boy, and turn off the mats. The remove module is designed to remove parts of the foreground that you have a shape over. So I've got a shape over this boy. I'm telling Mocha, I want you to remove this boy from the clip. So I'll turn that off, make sure I'm in the remove module, and I'll have it process the remove operation. This will create the clean plate that I need to use for the background in my... This will create the... This will create the clean plate that I need to use for the background in Nuke. All right, so we're done with that. Now that we've got our animated mats and our clean plate prepared, the next step is we need rotos on the boy. So I've got a nice script prepared for that. Here we go. All right, so our mission then is to create rotos for this character using the planar tracker and using it to assist in the roto process. So let's take a simple case like the arm. So we'll zoom into the arm. This is not a planar surface. However, it has aspects of a planar surface that we can use with our planar tracker. You see how the arm is rotating, it's twisting, and it's, again, not a flat plane. So what I'm going to do is I'm going to track that forearm and use it to create a roto for it. And over the length of the shot, let's say the arm changes by 50%. So I'm going to go to the middle of the shot and track 25% this way and 25% that way. That way the arm doesn't change so much shape over the length of the track. All right, so we'll draw a shape around this arm. I'll turn my mats on. And from this point, we'll track forward. And then we'll jump back to the place I started, and we'll track backwards. All right, so I now have some useful tracking data on this shape. What I need to do now is go in and just set some key frames to make it conform to the changing outline of the arm. And when I do, I'm going to get this. So this is the final shape that I got out of that process. Okay, next case, we'll turn that off. Here's another problem. The lantern. I need to have a mask for that lantern, but the lantern has two problems. One, because it's got glass in it, it's transparent. So the transparent region, the moving background pixels will spoof the tracker. So I need a way to tell it to ignore that part. It also, again, rotates. If you look at the beginning of the shot, you see how it twists? So again, I'm going to find a middle point in the shot so it's kind of equally distributed on both sides. I'll draw a shape around the solid parts of it, like this. Then I'm going to add a second shape to that same layer. So these two shapes are logically merged into one entity. Because here's the secret to the planar tracker. It does not look at the splines, it does not look at the shapes, it looks at the red region. All the pixels under that red mask are what it uses to track. So I'll track forward. Okay, and jump back to where I started and track backwards. Now in this case, I have used these shapes to create my tracking data. This is not going to be turned into my mask. I'm going to hide this, draw a new mask that covers the entire lantern. And then I'm going to lock the lantern to the tracking layer that I did a minute ago, and now I have a tracked mask. And to show you the real one, I'll delete those. And here's the real guy here. So we had a problem with the transparent, and I fixed it by having two separate tracking zones in one logical layer. Okay, the next problem we'll look at is we need a track on the shirt. And the problem with that is the boy's arm is swinging in front of the shirt and the lantern. These are going to spoof the tracker again. So what I'm going to do is I'm going to use the work I've done before. I'm going to leverage that labor. I'm going to start my track at the end of the shot. Let me zoom in a bit here. Draw my tracking shape. Okay. Now, I need a holdout mask for the arm. I can use the work I've done before, like this, to create a holdout mat so the tracker will not be spoofed by the swinging arm. Okay? If I don't do that, let me turn these off, watch what happens to my track if I try to track this without using the holdout masks. You see how far the thing has drifted because of the moving arm. All right, so we'll try that now again, this time with the holdout masks. Try tracking it a second time, and the tracker has a much better time of it. Okay, what we can do now is I'm going to toss that phony one and show you the real one. So this then becomes the final mat after we've done some keyframing and got everything all cleaned up. Okay, the last case I wanted to show you is tracking the head. Whenever you're doing a stereo conversion, you have to do a lot of body part tracking. And the problem with the head, as you can see towards the end of the shot, you see it's turning away from us. So instead of having a flat plane, we actually have a rotating sphere. Now the planar tracker is going to lock onto the side of the face and it's going to see it rotate. So I'll show you that. So let me draw a nice shape around here. Okay. All right. Let me turn off the mats. All right, watch what happens when I track this forward. It's actually going to lock onto the side of the face. You see it turning with it. And that's really not what I want. If I turn on our planar grid, you can actually see how that planar grid is actually rotating. So what I want to do, I'm going to do that again. Down here are the motion selections. The planar tracker looks for 5 kinds of motion: translation, rotation, scale, skew, and perspective. If I turn off, I can tell it what not to look for. So I'm going to turn off all of these motions, so only translation. Retract this guy. And now I don't get the skew and the perspective. Now the planar grid is tracking along. This is tracking data I can use to roto the head. So I'll turn that off, go back to the beginning of the shot. I'll delete that, and I'll show you the real head. All right, so this is the finished roto that I created using that data. One other unique combination is when you're doing a stereo conversion, you don't just have a mask for the head. You need eyes, nose, ears, mouth. We can reuse that tracking data to make all those other parts go much more quickly. So I'm going to turn this off. I'll hide the head. I'm going to add a roto for the ear. All right, so here's my ear shape. And as you can see, it's not tracked. It has no motion. So all I have to do is connect that ear to the head. Right there. Now the ear will track with the head. The problem is, over the length of the shot, the track drifts. Not a problem. I'll go to the end of the shot, select my shape, reposition it, then I'll scrub through the shot, looking for the greatest excursion, where it slips the most, right about here, and apply another correction there. And now I have a shape tracked for the ear. I'm now ready to export all of these shapes into Nuke in order to do the stereo conversion. So let's see how that's done. I'll delete that bogus ear guy. I'm going to turn on all of my roto shapes here. All right. So these are all of the mats that I built in order to do the stereo conversion of this character. To export them, all I have to do is turn on the ones that I want. I go to export shape data, make sure I'm talking to my Nuke. I have 3 choices. I can export just one layer, or all of them that I've turned visible, or all the layers in the whole job. So I'm going to say all of the visible layers, copy it to the clipboard, switch over to Nuke, and I'm going to paste this right up here and attach the viewer to it. And there are all those shapes that I just did in Mocha. The last step is I have to do the depth grading on each of those shapes. I needed all of those individual shapes for stereo conversion because I need to finish up with this. Let me dial down the viewer gamma so you can really see the depth grading. I need a different depth grade on each part of the body. which is why I needed all those different shapes all over the body, including, look at the ear, I got my ear here. All right, so how do I do that depth grading? Well, I'll show you right here. In Nuke, I'll bring up the roto paint node here. Each one of those shapes came into Nuke looking like this. So let's take a look at the head shape. Okay, I can adjust the brightness of the head, and when I do, that's going to move it front to rear in the camera. I also have feather and fall off adjustments. These help to shape it. So let me show you how that affects the mesh. I'm going to switch over here to my 3D world. Here is the boy, and there is my head shape. All right. So I'll show you how this affects the shape, the appearance of the shape of the head. Remember, I showed you that I can adjust the brightness of it, and that moves it front to rear. So that's my depth control. Now I need to shape it so it doesn't look like a flat cardboard cutout. So that's what the feather and fall off are for. As I increase the feather, what it's doing is it's putting the bright spot at the center and then tapering off the black at the edge. But that gives me straight edges. I want rounded edges. So that's what the fall off does. There. That's how I get the nice rounded edge. And now this boy is articulated and dimensionalized over the length of the shot, and he'll actually walk through the mesh. So I'm using those, the rotos from Nuke, from Mocha, to give it the depth grading and then texture mapping the image back on top. As far as the background goes, because we have a background plate, I'm going to hide the boy, turn on the background for you. Here is the background plane. And you remember that bulge that I brought over, that white moving mask? I'm going to show you how that works. Remember this guy? Now I've applied the gradient to it. So you remember how this guy's already animated from, kind of brought him in from Mocha. Okay, so as I turn that on and off, that disappears, all right? So we'll look at the 3D side. There you can see the bulge, and here you can see that bulge mask and how it has influenced the shape. Because I want that rock wall to come towards the camera. All right, so I've got my boy and my background. All I need is my stereo cameras. Okay, and now I'm ready to shoot my stereo shot. Let me turn my viewer gain back up, and we'll home the viewer. And now I've got my left and right views. Most importantly, let me jump to frame 1 and zoom into the face for you. Because I put the boy on a separate layer, watch the background, how it translates, shifts relative to the foreground. There's actually a displacement going on because they're on a separate layer. If you don't do that, then what you get is stretched. If you use the rubber sheet method or simple displacements, it stretches those edge pixels. You don't get that motion, and you have to go in and do stereo paint to fix it. So it becomes a very labor-intensive process. So there you go, using Mocha and the planar tracker as a roto assist to create articulated rotos for stereo conversion.